Okay, welcome back again. We're going to start our second session in the morning. And please, I'm going to welcome Mr. Werner Bauer. He's the head of and president of WtERT-Germany. And also, he's a vice president of the WtERT, the Global WtERT Council, in charge of the global development. He's going to present us today the reassessment of the waste incineration plants in public communication in the EU, European Union. So I'm going to give the floor to Mr. Bauer to make the presentation. And thank you so much for coming, to Hangzhou for, making this very interesting presentation.
Thank you, Reda. Thank you. It's my pleasure. It's my honor to be here. Thank you, President. Thank you, Niklas. I don't know whether he's just joining us. Thank you, professors here, and special for students, because you are the future of waste management. You are the future of climate. Hope not to change so much. Much more better here? That's no better. Thank you. I will tell you how it comes that we need a reassessment of the waste incineration plants. And especially, and I took the name waste incineration, not thermal treatment. You will see. I love this expression /methane emissions in waste sector to curb climate change. Where does it come? What is it possible to that waste management combats climate change, or is a chips like this? No. What now? Okay, thank you. So let's make a short view about European waste management, and we start in 2005, and it comes that we have this tax instrument that in July the 1st of 2005 we have this German landfill ban, and this was only possible with energy from waste. Besides, it's not possible to bring the waste only to recycle, or you have to have another decision. And this is especially also a possibility for me to introduce my company, because all these pictures, not the first one, but this and the other one, are examples of my engineering work. We are here, we closed the landfill over there. But this, I think this belongs together. You have this landfill tax, no landfill anymore. You have the other possibilities with energy from waste. So you can close the landfill. This is a small one, just as a good imagination. And this is especially has a possibility that to reduce, reuse, and recycle comes up, because we raised the level of money to pay for waste management. Though it comes effective that you can see, this is also an example of my work. The closing of the landfill is combined with a sorting plant. And here you can see some operation with waste paper. This also is one of our plants. Before, this was a composting plant, and after this we rebuilt this to a fermentation, to a digestion plant. So now we are about in, let's say, 2000, or and it's so that the we can know it in 2010, and it's possible that the scientific world can look back. What does this mean for Germany? From 1990 up to 2010, you can see that by phasing out landfilling of untreated municipal waste brings a total of around 56 million tons greenhouse gas alone for Germany. And when you bring this up to the European level, this is also research work for I guess 2 or 3 German companies. This is about 200 million. This would bring about 200 million greenhouse gas or CO2 equivalents when you close the landfills in all the countries in Europe. Thank you. Should I? Yeah, thank you. So this means also in Bulgaria, in Italy, or in the eastern parts of Europe, they closed the landfill and came to the level of Austria, Dutch, and Germany. This will bring 200 million equivalents. So, but now the idea of the German environmental was to tell this the European Commissioner and to discuss about this, how to enhance the speed to close the landfills. And it's credible, but it's not possible. They don't like to do this, and especially you can see in the European situation, this is they more discuss about how to get the democracy, how to stay in peace, or how to react against what now was going on. And so we can say that the disappointing results of the climate conference in Copenhagen. You can read it. You can get the presentation. We can further. For me, my part is especially in WtERT is to think to reduce the complexity of all these ideas, of all this what was happens, and to make it more clear, especially this figure from other presentations, and we redesigned this graphic just to make it clear that this all is landfill, and this is all is in Europe. We have to bring on maybe the level of 1 or 2% only goes to landfill, but all the countries here have their own ideas. They will do it a little bit, but they don't wanted to speed up their development. So let's see. This is one for Mexico. Just even for Mexico, you can spare 60 million CO2 equivalent, but it's not so. I can go further. Okay, so we have this tax instrument. We have the energy from waste. We have to reduce, reuse, recycle. We have, especially, we have everything in Germany. But you can see that also we have the mass of the amount of waste increases, and so the idea of zero waste in the European level comes up. And this, I think, I should fully respect of the people in the commissioners and the European Union, but I think we have to say Europe forgot that the sustainable waste management has some good answers for climate change, because they start, the actual policy is they start with ideas to change products in long term and foster recycling, which is very necessary, but it's not this. You will not have results today or tomorrow. You will have results in 10 or in 20 years. And so I think we have to, we have to vote for a reassessment of what waste to energy and incineration plants can do. And to the idea of changing products and foster recycling with the results of in 10, 15, 20 years is good. But the report of the International Panel of Climate Change calls for, we have to do now. We have to now reduce greenhouse gas. And the first possibility for me, the best possibility for me is closing landfill. And this is only possible by building more incineration plants. But this is, when I take this expression here, you will understand this, but when I see that we are here in something like a bubble who are with engineers knowing a lot about waste to energy and knowing a lot about incineration plants. When I go outside and I vote for more incineration or more thermal treatment plants, they will get afraid. So I think it's necessary to see what's going on. And we have to discuss it on a political focus. And even we can see that we cannot address this to the politicians. So we have to address this to the environmental parties, to the NGOs, and to the people. So reassessment of waste to incineration plant. The assessment now in the public in the European Union is same like in Africa or in most countries, that they are afraid and they think that to burn the waste keeps a way to recycle the waste. And for in this time, I want to tell you that I try to be very clear in the expressions. We always say that incineration plants or waste to energy plants are for waste that is not recyclable. I guess you will agree. But I will say we will change this. Waste to energy plants or incineration plants are for those waste who is not recycled. Not recyclable, who is not recycled, because the operators of the waste to energy plants are not responsible for this, what goes on before. So we need to discuss a little bit. We need to see what's going on in the world, and it's very necessary to see why this is so important, what in Europe is, because I recognize remember, Yuri, you told me that your people in Brazil, like the operators of landfill, told you that in Europe you go back from incineration plants, and though we have this has a global impact, and especially when we see that in the World Bank that about 70% now goes to landfill or dumps, we have to increase the speed of thermal treatment. Especially when you see that the waste generation goes by 70% up to 2050. So in view of this gigantic task, every discussion, I guess, and every cooperation between these two bubbles, recycling bubble, waste to energy bubble, or zero waste bubbles, or people who don't know anything about this, is necessary, because it's also necessary for it brings jobs in poor countries, and it brings this turnover of waste management business in Germany. It's about 70 billion euros, so it's a lot of jobs in every part in the world. So what is to do? In my idea is we have to communicate this to experts and NGOs in waste management community. That's okay, but also in the energy, heating and power supply community, in the climate change community, and always hear about people it's one week ago where one friend of the Minister of Environmental in Germany told me that he was the first, met one of the energy environmental or from another part of the ministry. So we also have to clarify the communication of the essential, what is solid waste management, to explain interconnection between landfill and greenhouse gas, and between waste management and heat supply. In Germany, 16% of district heating comes from waste to energy plants. So it's very necessary to see this. And what I guess what we can do is now I introduce you to the WtERT decision support system. The idea, maybe let's see, it's a starting point, or we are in the middle, to bring all this discussion or this information together. And I will like to have a few minutes more to tell you how we do this. I think we come to reduce the science paper. I think, very complicated to read. Even for me, who write science paper for myself, it's complicated to read or to understand. And so we have to reduce this complexity for the people and for the NGOs, especially when they are very single-minded and just say recycling is the best, and don't hear anything, don't want to hear any other things. So that's what we do is we make, this is one expression or one picture of a case study. This case study is maybe here a transfer center in Tunisia, or here it's PadMed. It's a initiative of reusable sanitary pads in Kenya without plastic. It's very necessary, and it doesn't have anything to do with waste incineration, but it's a way of cutting these sharp buttons, bringing the people together. Here it's a composting plant in Romania. Here it's ensuring clarity about the amount of bio-waste helps to reduce it. Well, this is something like how to make bags out waste from waste management. And this is a waste-to-energy plant in middle of other examples. And let's see how we bring this, how we want to make filters, and how we want to help decisions making. I want to show you like this, how we do this. Oops. Sometimes it does not work, but you get it. I can explain when you click one of these case studies, there is an explanation about what it is. You can it's necessary. Okay, just wait. Yeah, thank you. You can even, especially here, you can see this is a mechanical biological treatment plan. When you click it here, you can see how it works. You can have pictures. You can see. You can imagine very fast how this works. But also you can see on the right side the company. You can click to the company who is responsible, who is possible to do this. And I'm very sorry. And you can come into contact to this company, and you have to see what's going on. I tried to explain this with pictures, but it will not work. Yeah, now it goes. Now here it is. You don't need this. I can make it file. The idea of making this decision support system sustainable is to bring in the knowledge even from companies, the knowledge from companies who do recycling, who build especially maybe our operators of waste to energy plants. Yeah, keep on. Thank you. Okay, so we also have beside these case studies, we have recommendations. The recommendation is that one professor tells only this is necessary for waste management and climate change. Only one sentence, or this is for 20 years the idea or the essential I've learned. And so we have case studies and recommendations, and the filters are connected to countries and different possibilities. Sorry, will not work. I guess, yeah. I guess come to ground. So when you can see, you have a starting position on a strategy development. When you need your decision get helped, it's necessary you have help in maybe let's see, this is Hungary. Is this not a problem with waste generation? Is it a problem? The waste generation is only a problem in Italy, UK, and France. And though you have a case study for how to reduce waste, or here when you see landfill targets and you see different countries, this Austria and Sweden has no problems with landfill targets, but Croatia and Slovakia has to reduce the landfill, so they need strategies to reduce waste. So we have the case study about conversion a lignite fire plant to a waste to energy plant. This is maybe when you make clean the cities. This is a case study from Tunisia, how they rebuilt a collection center in Tunisia. There you can read it here. I want to speed up. You also have the possibility, how is a composting plant of sewage sludge? And here you can, when you click it, this is only the first picture. It's maybe you can scroll down a little bit and you can see lots of explanation. You have at the right side, you have the company, it's Gore. You click on Gore, you have the explanation about what is Gore. You can see you have a man who is responsible for it. You can click on him. You get this on WtERT.net, you get his personal profile, and you can click on his send message and you are directly in contact with him. But the idea is that people need help for their decisions. They get see what's going on. Maybe when they need a thermal treatment, reducing emissions, they get contact to this case study and they get into contact with this company. It's the same. When they have a landfill, and we all told about landfills are so low and no costs in landfilling, but we have to explain what this means, that the costs comes in the future. And this is a case study how costs from a landfill come today, which is closed for 20 years. So as I end with this picture, that I want to tell you that incineration, recycling, landfill, and let's something say, let's zero waste ideas meet people in different bubbles. We have to bring them all together and we have to discuss over these frontiers. And I would like to do this on a global level. So thank you very much for your attention.
Thank you so much, Werner. Come again. We have a question now. Yeah. Thanks so much for Werner for the presentation. And you know that WtERT.net is one of the projects within WtERT, which is the aim is like to create some sort of open source database that englobe information from all over the world regarding to sustainable waste management. And the objective is to put a lot of information to be accessible to everyone, free and online. Okay, so if there's any questions, the attendees will ask. Feel free to ask any question. Or of course, you can get in touch with Werner, and we invite you to get into the WtERT.net and create your profile, share your information, papers, and so on. So it's going to be very interesting, to exchange and collaborate online.
And I think it's necessary to tell you the business idea, because to do the work in WtERT.net every day, it means people, means the staff. It's very expensive, and if there is not a great sponsor, would be great. We need some small change from the companies. So this company pays us per year, and the other companies pays us a year a small fee, a few $1,000s, but in the maximum when we enhance this program, I think it would be even a good business idea. And this, everyone, Yuri can do it. In Jordania, in South Korea, you can do it. Check out your companies in your country and make with them, maybe I can give you a draft about this contract, and they come in. But what is necessary that on this global level, maybe we have to make this assessment of these papers or of these abstracts that is necessary, that we are on our way on a sustainable waste management or sustainable circular not society circular, not economy on a circular society, which is necessary.
Thank you. Thank you so much. Very little change on the schedule. We're gonna introduce Professor Lisak from Singapore, and then you're gonna follow up with Professor Anna. So Professor Lisak, he will join us from Singapore, okay? He will present the beyond conventional waste to energy, the promise of high temperature slagging gasification. So Professor Lisak, he's currently the professor at Nanyang Technological University, and he will join us online to make his presentation. So Professor Lisak, could you hear me?
Yes, I can hear you. Can you hear me?
Oh, very good. So we're very, very pleased to welcome you to the Global WtERT Congress, where you can share your screen.
Hear me clearly. I apologize, I could not be with you there in person. There was some technical issues. I had to stay behind in Singapore. So for today's presentation, I really want to give you an example of what we do around waste to energy in Singapore, and where we look into, which might not be really aligned to what other countries are doing. So just to give you a background, in Singapore, we are well established with waste to energy. All our municipal solid waste is being treated in incineration. So we are very well acceptable and established in terms of having incinerators in Singapore. But incinerators generate ash. And Singapore really cannot accept a high volume of ash because we do have only landfill that is filling up slowly, and by 2035 it is expected to actually run out of space. So as a part of looking at how to complement incineration, we are studying high temperature slagging gasification as a countermeasure for not generating ash. Okay. So I'm going to present you work beyond conventional waste to energy, the promise of high temperature slagging gasification. So in the context of saving the space in a landfill by generating less residues that have to be landfill. Okay, and I'm going to present it even one step further, where I'm looking into conversion of sewage sludge in gasifier, as opposed to treating only municipal solid waste. So this technology really was considered for sludge treatment here in Singapore only. In Japan, the treatment of sludge is being about 10% among municipal solid waste. But for Singapore, we are now looking how we can eliminate sludge in most efficient way by recovery of resources rather than only energy. Okay, so just to give you the, can you see the slides?
Very good.
Yeah. So just to give you background why we do it, we have a lot of sludge in Singapore, 200,000 tons per year of dewatered sludge, 30,000 tons per year of dry sludge. And then this sludge is being treated in incineration by external providers without energy recovery. So it's just a treatment method. And we generate about 28,000 tons per year of ash that ultimately ends up in our only landfill, the island offshore Singapore, which is called Semakau. Additionally, we directly dispose 15,000 tons per year of waterworks sludge, so simply drinking water treatment sludge. And that goes directly to the landfill as well. So actually, the ash and this waterworks sludge contribute significantly to filling up the landfill. So we've been given a directive from our agency that deals with the sludge to simply look at alternative technologies for sewage sludge treatment, so we limit the disposal of ash to the landfill. And I'm not sure if you are aware of, or if you know the history of NEWWTR in Singapore. New water is nothing else as processed water, so from wastewater, water being recovered, and you can find in a shop a water labeled new water. So this is basically wastewater treated or recovered water, right? So Singapore, from long time, is branding this sort of waste-derived materials in such a way that they do not link to waste. Okay, so that's why the name new water. So with the same concept of generating new water in Singapore, now we are looking at how to generate new sand. So that name new sand is already protected in Singapore, and it refers to a slag that comes from gasification technology. So slag can be used as a replacement for sand in construction, land reclamation, and a few other applications. And for that reason, we label it as new sand. And here saying that, I just want to make everyone be aware that this is the direction I believe we should all follow, that wastes are nothing else as resources, either misplaced or mistreated. And if we want those resources to be acceptable in the society, they cannot bear the name of waste derived. They cannot have a link to waste as such, and they should be branded separately. And Singapore is really good at it. So as new water, now we have new sand, and actually follow up the same ideology. We have also new oils, so oil that is not processed from fossil fuels directly, but processed from polymers, from plastics. So we do the research on this technology in our demonstration plant, which treats around 11.5 municipal solid waste per day. And it has capability to actually do research around different feedstocks, different gas treatment technologies, syngas upgrading, recovery of energy, flue gas treatment, and as well as low rate heat recovery. So what we do, in short, we take different residues. So in this study, we concentrate on different type of sludge, as well as ash that comes of the sludge treatment, and utilize our demonstration facility to actually test how it is useful for generating new sand out of the treatment, and looking at different replacement ratios between sewage sludge and municipal solid waste. And that slag as new sand would then enter into different applications such as road construction, non-structural and structural concrete. Slag from municipal solid waste in Singapore is already not standardized, but basically acceptable for reuse by our environmental agency, to such extent that our agency actually built the plaza around the environmental building where they reside using this type of material. So this is the overview of the process that we are implementing for studying sludge treatment. So the most important is the gasifier, high temperature melting furnace, where we feed the waste. This would be municipal solid waste or mixed with the sewage sludge. Alongside, we need to use biomass charcoal as auxiliary fuel and limestone for the viscosity of the melt that comes down from the bottom of the furnace. So the temperature profile in the furnace is very high at the bottom because we feed here oxygen and rich air, and have the biomass charcoal to generate extreme temperatures up to 2000 Celsius degree that ultimately make the ash that comes out from the gasification melt through the bed and exit at the bottom. where it's being cooled, rapidly cooled, and in this process we separate slag from metal granulates. So metal can be sold and we sell it. Most likely this goes to like India for smelting and processing, and the slag, which is new sand in Singapore, can be used for construction. Naturally, this process generates syngas that in a current form, it's being combusted in secondary combustion chamber, and through a heat recovery in a boiler, it goes to the power generation through steam cycle, and flue gas is being then treated before final release. So this technology still generates fly ash out of the flue gas treatment, and that is currently the only residue that goes to the landfill, but it's about 3% when you treat municipal solid waste, a bit higher if you treat sewage sludge. But it's still an improvement from about 20 to 15% generation when we talk about incineration ash, and that makes it so attractive for Singapore in terms of going away from ash generation. So here is just a representation of different sludge that we treat in Singapore. We actually in Singapore maybe have not the best way of segregating sludge. So some of the industrial facilities and domestic sludge would be co-mixed together. So our sludge tends to be a bit more contaminated. And then, as I mentioned, there are two facilities that treat commercially the sludge without energy recovery. And we look into treating that ash as well, so it does not end up in the landfill. So one process has a mixed ash and another process can separate bottom ash from fly ash. So actually having the different type of sludge and ashes, we developed different mixes to feed into the gasifier at low and high loading rates as compared to MSW. And intention is to simply push the boundary of the technology to see how far we can go with the sewage sludge treatment as compared to what traditionally this technology is set for municipal solid waste. So as I mentioned, the Japanese facilities, this technology mostly operational in Japan, treats maximum about 10% of sewage sludge among municipal solid waste. But we do push it even up to 50% of sewage sludge and municipal solid waste to see how the process will react. So out of the experiments that we conducted, feeding municipal solid waste together with different ratios of sewage sludge and ash replacement, we noticed that we achieve stable slagging process, which means that delivery of metal and slag is not affected by the introduction of sewage sludge. We see that all the mixes that we implemented are feasible to be treated in high temperature melting furnace. Also, we achieved comparable energy recovery efficiency as compared to pure MSW treatment. And we actually compare with the NEA regulations. So the emissions that we produce are nothing different than typical MSW operations. This is actually achieved because in some cases, due to SOx formation, we have to look at different sorbent for the air pollution control system. So typically this would be slackline, but for the high content of SOx, we have to actually look also into bicarbonates. And this might be a slightly more expensive, but it's more effective in order to control the SOx. So we studied that as well. Out of the process, we generate the slag. So we actually had to validate if the slag is reusable as compared to municipal solid waste derived slag. So here you have a bunch of elements and batch leaching tests, standardized tests, as well as TCLP tests for the slag material, and results from the concentration which we investigated in the slag, and compare to regulatory level for TCLP and EU criteria for inert materials for batch leaching, as well as so-called National Environmental Agency reference values, which are operational in Singapore when you standardize material that is waste derived for reuse. Okay, so for TCLP, there is no issue. All the elements are within the regulatory levels. For batch leaching tests, which is in Singapore more important because that allows you to directly use the material, you can see that basically we meet EU criteria, while NEA reference values are more stringent, and some of the elements actually are out of spec, but to very little extent, which is acceptable for regulatory approvals for reuse. So those are typically as spikes, and as you know, this material is rather heterogeneous. So naturally, on a long-term basis, you don't see such spikes occurring. The levels are much lower. Okay, so basically from environmental point of view, this material can be reused. But let's have a look at the geotechnical properties of this material. So here you can see different pictures of the slag as developed from different mixes of sewage sludge and ash, as well as MSW. From the appearance, they look more or less the same. Some of them change slightly color, but there is no much difference to them. If you look at the size distribution, so blue lines are for different mixes, while the black line is for the sand itself. So we are within the specs of the sand, and that is allowing us to consider it as a sand replacement for the construction industry. Also, we investigated standardized tests for how to categorize slag among the construction materials. And what we found out of the standardized test is that we meet the grading of GF85, which is grading for fine aggregates. So this is exactly what sand is used for in construction. So we can now replace, or looking at the replacement of sand with new sand or a slag in concrete. This is a big deal because Singapore is one of the biggest importers of sand. So using our domestically developed sand replacement for construction is a big deal. We also investigated the use of the slag in mortar together with OPC to see how it behaves in terms of the strength, compressive strength, to evaluate its use for non-structural and see if it could be possibly used for structural applications. So you have from here down all the mixes that we investigated. We compare ourselves to the slag which was developed only from municipal solid waste, as well as typical mortar of OPC and the sand. So you can see that this graph is relatively boring, but in this case, boring is good because as compared to sand, the slag ultimately performs in similar way if given a slightly longer curing time. So some initial changes could be observed for some of the mixes for the initial strength, but as curing time goes on, they catch up with more or less the sand mortar. And this material perfectly fits for non-structural applications, which requires very low strength. And even looking at this higher strength concrete for structural applications, it actually generates a promise as well. So in Singapore, the use of slag or new sand is already approved for non-structural applications, while for structural application, this is something that we are now currently working on.
Greg,
so to just conclude, yes?
If you can just make shorter your presentation, we can
sure.
on time.
I'm already concluding. So basically what I'm trying to providing here is that we should be looking into advanced technologies that also looking beyond incineration for offering also material recovery that could be used in various applications, and slag from gasification offers you that. So alongside, we develop now a new technology for sludge treatment, and hopefully in the Singapore we will see a commercial case of this technology very soon. With that, thank you very much. I think the only thing that is left, acknowledgement for the team that works on this project, and I welcome any questions. Thank you.
Thank you so much, dear Professor Lisak, regarding your very interesting presentation. And thanks for sharing very valuable research and data, for all the attendees of the Global WtERT Congress. So I'm going to ask very quick the attendees if you have any questions, so we can move to the next speaker. Any questions? Okay, Professor Huang. Okay.
Sorry, I cannot hear.
The ash content for the sewage sludge.
So the ash content is relatively high, especially for the waterworks sludge, and for that reason, it's not being treated in incineration. I'm not sure if I get the whole question. So ash content is quite high for these materials. If you refer to what we generate as ash, we generate about 5 to 6% of fly ash. But okay. I don't think I got the full question, so could repeat if I did not answer.
It's good. It's a good question. Okay, perfect. Good.
Okay, thank you.
So the next question from Professor Arun Sumat from India.
How close are the values between experimental plant and the operational one in at least few parameters like TCLP and as ash content he just asked about? Yeah. How close the values between experimental and the operational plant?
So we are actually unable to do experimental slagging process in the lab. All our data that comes in this research comes from our demonstration plant. So already commercially resembling plant.
No, my question is, do the values match between experimental handling 11 tons and maybe your hundreds of tons of the operations?
Oh, yes, they do match. We compare them with the Japanese values, and they match.
Okay.
So the process is comparable.
Okay, thank you so much. Thank you so much, Professor Lisak, for your presentation. And
thank you.
Well, see you next
Hope
time.
Hope to be
person.
with you next time. Yes.
Yeah, definitely. Yeah. Okay, bye-bye. So
thank you. Bye-bye.
Bye-bye. So now we're going to move to our next speaker before going to lunch. And I'm going to introduce Professor Anna Kurbatova from WtERT Russia. She's going to make a presentation today regarding the energy management of municipal solid waste in the context of low carbon development. So just for the time to set up. I'm gonna. Okay.
Good afternoon. Good afternoon to all the attendees. My name is Anna Kurbatova. I am Associate Professor of the RUDN University, Moscow. And our topic of discussion today is energy management of municipal solid waste in the context of low carbon development, mainly in Russia. I would like to start the presentation by talking about energy utilization. Okay.
Could you speak a little bit, louder? Yeah.
Okay.
Or do you want to use my micro?
No.
Yeah, much better.
Okay. Energy utilization is an element, of waste management. It's a significant factor in the development. Okay, thank you. It's a significant factor of the development of the circular economy as a key factor in the growth of low carbon economy. Energy utilization, you know, is the extraction of heat in energy from production and consumption waste. We are talking about a repeated cycle of creating added value from waste. Sorry. And sustainable development is an organizing principle within a low carbon economy. It implies the use of natural capital for human development purposes, with the provision of conditions for sustainable ecosystem homeostasis. You can see at this slide the Chinese idiom. When you are wealthy, think about poverty, but don't think about wealth when you are poor. This idiom means that thrift is the best policy. Be modest, work hard, and be economical. So, energy security in Russia. Energy security is a key characteristic of national security, you know. It ensures the needs of the national economic complex and citizens in energy resources. It also needs the export and import of energy resources for production, consumption, and value creation. Both Russian and foreign researchers discuss energy security and sustainable development in terms of green economy, which is very relevant and topical issue today. There are a few problems arising from the discrepancy between the principles of green economy and energy policy. These problems lie in the field of limiting extraction, processing, and production of energy resources. The problems is also the compliance with the environmental well-being of territories, as well as rather strict environmental safety standards in terms of green economy. So next slide. At this slide, you can consider figures in terms of emissions from mobile and stationary sources of production. And the last figure shows us economic entities processing, extraction, and production of resources. The state policy agenda and the field of economic systems, sustainable development, and ecological space improvement is fully implemented. As a result, emissions of all types of pollutants for all types of economic activity have significantly dropped. You can see at these figures. Since 1990, the volume of greenhouse gases has been significantly reduced, mainly in energy sector, But now the decline has stopped. Why? What do you think? We can explain this by the technological limitations, which doesn't allow us reducing greenhouse gas emissions without a complete restructuring of the work technology. The volume of investments in fixed assets significantly increases the expenditure part of mining and energy generating enterprises. In turn, the trend increases systematic, economic, and financial risk. This is because a high resource base leads to a multiplier increase in the cost of energy consumption. Okay, according to the results of 2021, you can see this slide, almost all Russian energy companies were highly appreciated by World Wildlife Fund. We can say that the concept of the green economy in terms of environmental protection, of course, is being implemented quite successfully. In general, we can come to the following conclusions. The trend of preserving and protecting the environmental well-being of territories is positive. Achievements in the field of low-carbon economy are offset by the price factor, and the production factor. The volume of investments in fixed assets in the field of environmental protection is significantly increasing. Let me say a few words about the drivers of energy utilization growth. Drivers of energy utilization growth. Energy utilization, together with the wind plant and solar plant, will partially cover the high cost of electricity. This is due to the use of the heat removal for economic needs. In other words, redistributing the value of the additional product to the total generation costs. Reducing the share of coal-fired thermal power plant is a factor of green growth and sustainable development in the green economy and be related to circular economy. This is a great potential for the development of green, low-carbon economy in the field of waste, solid municipal waste processing. And it's both from the point of view of obtaining renewable energy from waste and from the point of view of a rational use of land resources that were withdrawn from economic circulation for storage facilities and landfills. Okay, a little bit about energy production. You can see at this slide that the target indicators in Russia for the development of the municipal solid waste management industry in Russia provide for an increase in the share of waste recycling by incineration of non-recyclable waste residue with energy production from 2% in 2019 to 24% in 2026. And you can see at the same time, the task is to bring the level of waste recycling into secondary raw materials and composting to 24%. The share of disposal of such waste will decrease from 93% to 36% in 2026. Now, you can see now analysis of international experience in the field of municipal solid waste recycling shows that energy waste disposal is an important direction for the development of the circular economy at the same time, the development of the waste processing industry should be considered as an important activity in forming the market for environmental goods, works, and services. And many countries of the world continue to actively build, you can see, actively build plants for generating energy from waste. Despite certain advantages, the use of technology for creating energy from waste causes concern among the public, both from the point of view of the utilization of useful secondary raw materials, possible emissions of pollutants, and taking into account, the high cost of such projects for the construction of incineration. The problems of emissions of harmful substances into the atmosphere is technologically solved, but it can cause social concerns. Therefore, an important task is to analyze, take into account, and evaluate all environmental, social, and climatic aspects in implementation of said projects. This chart shows us methods of solid municipal waste management in selected sites and agglomerations of the world. And I would like to focus that you can see that as for the use of technology for thermal processing of municipal solid waste in the world during the construction of new facilities, 458 thermal processing plants with a total capacity of about 110 million of new tons of such waste per year were built in the world during 2008 to 2015. And China is a perfect example for the creation and development of an industry for the production of energy from waste. And the dynamics of the development of this market is proven by the following data. If in 2004 there were 50, correct me if I will mistake, there were 54 waste to energy processing plants in the country, which processed 4.5 million tons of such waste per year. Then in 2019, there were already 389 such plants that allowed 121 million tons of such waste per year. And thank you. This is, you can see the Russian landfill. It's not far from Moscow. And analysis shows that the low percentage of municipal solid waste utilization in Russia is associated with the insufficient development of infrastructure for the processing of such waste. There are currently 243 complexes for the disposal of municipal solid waste, 53 complexes for sorting waste, and about 10 incinerators in the country, but 4 incinerators are located in Moscow. And there are many disadvantages in the current state of the waste processing industry, such as insufficient economic interest of enterprises, low technical level of applied technology, a shortage of modern equipment for their processing, and a significant flow of waste transported from the city. Now, the construction of incineration plants only in Moscow region will prevent the creation of new landfills for the placement of municipal solid waste. ensure savings and land resources, and reduce greenhouse gas emissions. And so processing of 1 ton of municipal solid waste to produce energy using the great combustion technology allow us to reduce about 1.01 tons of CO2, including a reduction of 0.5 tons of CO2 due to fossil fuel savings. At the same time, the burial of 1 ton of municipal solid waste without collecting landfill gas leads to the formation of 1.61 tons of CO2. At the same time, an environmental effect is achieved by reducing emissions of pollutants into the atmosphere from 10 to 15 times compared to the option of dumping waste at landfills that are already overcrowded in the Moscow regions. Now you can see the nice city of Russia, Sochi, and Barcelona of Spain. What about Sochi? Another investment project that also allow us to solve the problems of developing a low carbon economy is the construction of a municipal solid waste energy recycling plant, thermal processing, on the territory of Sochi with a capacity of 550,000 tons per year, with the production of 55 municipal megawatt of electricity. The formation of municipal solid waste on the territory of Greater Sochi is currently about 387,000 tons. It will take into account the adjacent territories of the Black Sea coast. For example, such cities like Tuapse, Gelendzhik, and so on. It's more than 600,000 tons. If we look at the constant growth of the population of the region and the increase in tourist flows, by 2025, the estimated volume of such waste generation will be more than 980,000 tons. Waste removal from Sochi takes place by the road to the landfill from Belorechensк, located 250 kilometers from Sochi. The collection cost, export and burial, transport and burial of municipal solid waste in Sochi is 4,000 rubles per ton with taxes. And an important tool in the management system for attracting investments in the infrastructure projects, including projects for generating energy, you can see from waste, is project financing. The cost of 1 ton of waste in Russia is from 5 to 6 times lower than in foreign countries, where the fee for receiving waste is about $20 per ton, which roughly corresponds to current price, to current levels in Russia. Other incentive measures include temporary exemption from income tax, provision of a site, and external infrastructure for the construction of factories by local governments, and tax refund from the sale of electricity. Okay. And conclusions. The one, energy recycling solves the problem of waste disposal. And the second one, recycling waste into energy has significant potential to reduce greenhouse gas emissions. Therefore, the use of such an approach allows us to solve not only the intense problems of waste disposal in a complex, taking into account environmental requirements, but also to obtain energy from, in fact, renewable sources to reduce greenhouse gas emissions, which is generally aimed at developing a low carbon economy in the country. And the third, the need to introduce green tariffs for energy from waste. And now, thank you all for your time and attention. I truly hope that my presentation today, 1 minute please, has given you a new way of looking at waste management. And even though we still now, have a long way to achieve optimal conditions in this field, I think that cooperation and mutual understanding is a key. And if you like to read more on this topic, I suggest you take a look at the paper that I have written with my good friend and my colleague from Jordan, Dr. Hani Abugdeis. Thanks a lot for the time and attention. Again.
Thank you so much. So thank you so much, Professor Anna Kurbatova, for your very interesting presentation. And we're going to ask you a lot of questions during the lunch, okay? And we're going to thank, Muhammad Abdullah, who's going to let us have a lunch, okay? You will not hold the essay, right? It's fine? Okay, perfect, good, perfect, good. So thank you so much. And then, let's have a lunch all together, okay? And I will leave you, right? Okay, bye-bye.